always liked life. I'm kind of curious how the future will look, what society will look like, what technologically will be possible, and so on. I'm emotionally not really down to not exist. So the fundamental logic of cryopreservation is that you are your body. So as long as we keep this around, for all intents and purposes, you are still around.
Dr. Emil Kinziora is a physician and biotech entrepreneur focused on extending healthy human life. After realizing progress in classical life extension research was too slow, he shifted toward medical biostasis, preserving life until future therapies are ready. Today, he co-founded Tomorrow.bio, building Europe's first integrated biostasis infrastructure. At Life Summit, Emil represents the frontier, where medicine, time, and long-term thinking meet.
All right. So we've heard a lot about different types of longevity. I pretty much represent the moonshot side. You know, when the supplements and the lifestyle changes are here and, you know, biotech is here, what we're doing is pretty much on the other side of the spectrum. And I've been doing this stuff for a very, very long time. So this is me with the blue tie here on the right side of the picture in med school. This is like 18 years ago now. I went into med school to do longevity in the future, right? And for me, longevity was always a two-part kind of discussion. Everybody is into health span, right? No one wants to be sick, and I said this in the opening, of course. This is the easy answer, I think. You know, it's a very tangible thing. You know, every day you can, you know, see if you're sick or if you're healthy, and everybody wants to, of course, health span. Now, my point is, and this is a kind of a growing group of people, when you're healthy, now you would like to live longer, right? And more people say, oh, no, now I'm healthy, you know, now I would like to also live longer. And, you know, it's a personal choice. How long? For me, the answer was always very, very long. At least, I want to have the chance to say I would like to live another day. And currently, I have not had any day where I would change that opinion. Now, if you ask people, 26% of people say, I would like to live indefinitely. We did this in the US, we did this in Germany, in Switzerland. It's pretty much all over the place, right? Every place it's kind of the same. They don't say I want to be immortal, because immortal, at least for me, is a very, very philosophical term which has almost no meaning. But indefinitely means kind of, you know, every day, one more day. And now we need to remember, while there is stuff that has good evidence that lets you live healthy, as of today, there is nothing, not a single drug, not a single treatment, nothing that lets you live longer. All of the stuff that you've been hearing about here, you know, NAD+ and senolytica and, you know, fisetin and, you know, partial reprogramming and you name it, all of this stuff has not been proven to extend maximum lifespan by even a day, not a year, nothing in humans. In mouse, or in cells, a lot of the stuff works amazingly. But again, my stuff that I did in med school in the past, when I wrote my doctoral thesis about, this always worked great in cells, this worked great in mice. And as of today, I'm not aware of anything of the stuff that I did in the past actually made it to the clinic. Bringing things from humans, from mice into humans is really, really, really hard. So what we're currently basically doing, I don't know if you know these types of curves. These are basically showing, you know, as people get older, how many people are still healthy and then how many people still are alive. You know, these lowest curves here, those were in the, you know, many years ago in the, you know, early 1900s, right? Where at the age of 50, pretty much, you know, half the people were already dead. And of course, if someone dies at 50 today, everybody would say, well, it's a tragedy, way too early, before their time. And of course, we have gotten better. Like now, more people make it to the age of, you know, 60, 70, or 80. So these curves get more square, right? That's what's called the squaring of the morbidity curves. The problem is, all of these curves, since the beginning of time, have ended somewhere between 85 and 95. So all the advances we've made, you know, you see as the years have gone by, and the red one that I added in, unfortunately, this is from very recently, like 2020. All these curves get better and better. You live, you're healthy for longer, but then at the end, it drops to being dead at the same time. And this kind of shows in a different way that whatever we do, we have not made it to live longer. And the reason for that is kind of, you see it in those studies. So this is rapamycin, one of the, the top compounds that is currently being discussed, right? And if you look at even in mice, the impact of that, it's a couple of % of extension of life, right? And then, as I said, stuff works well in mice, but then bringing it to humans, the translation is horrible. On average, couple %, like slightly under 10% of stuff that works in mice, then turns out to work in humans. Now, of course, a lot of people have started taking stuff when they have cell data or data in mice or whatever. This is, in my mind, not a great idea because it doesn't translate well. And then to make the story a bit worse even when stuff works, even if the drug has been approved, the FDA or the EMA says, this is a good enough drug, even then, the effect size on living longer is very small. 30-something % of those things actually extend life by any means. For me, unfortunately now, that's, to be fair, why I stopped being in academia, because progress in my mind has been way too slow for a very long time. The problem is that this stuff is really complex. This is a small part of what's going on in everybody's cells. Super complex processes, right? If you start changing something down here with some compound or some medication or some treatment, right? It's a very complex network, not something that I think we will be able to fully understand anytime soon or in a meaningfully way impact. Now, I'm not making a claim that there's no progress. Of course, progress is constantly being made. There's new drugs coming about and so on and so on. I'm making the claim that the optimism in the longevity field might not be as warranted as I would hope it to be. And I direly hope that I'm wrong. I just really don't think I'm wrong. And you kind of see this. So I come from cancer research, and you kind of see this. Cancer, I think, or the cancer research field, I think, is currently still the best example of that. This field has been spending billions and billions of dollars for decades and decades and decades, right? And in 2005, the National Cancer Institute, the largest cancer research organization in the world, has said, we would like, or our goal, not even we would like, our dedicated goal is to cure cancer, not make it better, cure by 2015. And of course, everybody is aware, 2015 now is more than 10 years ago. Cancer is still the second leading cause of death. Right? And since then, we spent about $500 billion in cancer research. None of that money is badly spent money or anything like that. Right? Again, progress is being made. But from what was predicted back then, what was the declared goal of the best people in cancer research, and what we had actually achieved, these things are very, very far apart. Right? And if you talk to the leaders of research institutes or biotech companies, if you talk to them over dinner and ask them, guys, how many extra years of life, of healthy lives, do you think we will be able to get? Pretty much, that question. What makes you optimistic? Where is your optimism coming from that we will get a couple more, a couple of decades? Everybody I think says, if I'm healthy, I would like to maybe live to 100 or 120 or whatever. You need to remember, average life expectancy isn't even 80 in most countries, right? So that's a significant improvement to make it to 120 while healthy, right? That's 40 additional years of life, right? And if you ask them, even let's say only 5 to 10 years, you will figure out no one is optimistic. This optimism is more like everybody who leads organizations, bar very few people, but if you ask them to extend how high the probability is to extend more than a couple of years, the optimism goes completely away. And again, that is because all of these people, of course, know and have been working on this and really have an emotional connection almost to how difficult this stuff is. So in my mind, unfortunately, the big question is, do you want to hope? Do you want to hope that this is all getting better and that we're going to make it? Right? And maybe AI will, in fact, just make it work for us. Right? But if I would believe that, I could just be on the beach right now. Right? And why would I need it all work if I think AI will solve all our problems tomorrow? So if you believe that, I would get a one-way ticket to some nice beach. Or do you want to hedge? And I've decided, okay, I'd rather hedge. And if I'm wrong, either in the way that AI will solve everything for us, amazing. If I'm wrong in a way that, we will soon figure out how all this longevity stuff works, and I just take the treatment or the pill or the multiple treatments or whatever it is, amazing. I'm going to happily do that as well, and I'm happily going to admit that I was wrong. But till that is the case, I've decided that I'm working on the backup. And this is what Tomorrow.bio does. This is the backup. It's the stuff that you know from science fiction movies. Where instead of, when you want to fly to another star a couple light years away or whatever, where the journey takes 20, 30, 40 years, right? Instead of having the actors age, they're being cryopreserved, they're being preserved for a bit, or frozen, or whatever the movie calls it, put into stasis, right? And then 40 years later, they wake up without having aged a day. Of course, in our case, it doesn't look as nice as in these movies, but hopefully it's also not as dystopian. Usually this is a plot device to have to set up some dystopian future. But it's the same fundamental idea. You kind of bridge time into the future until all the rest of the world has figured out, in fact, how longevity and life extension actually does work. Because my point is not that we will not figure this out at some point. My point is it's too complex. We will not figure it out in time for most of us in this room. And of course, my argument being probably for all of us in the room. And again, if I'm wrong, happily wrong. It's not this. It's not freezing people. Right? So whenever I give interviews with journalists, I always need to fight against pictures that have ice cubes or brains in eyes or frozen hands. And usually I lose those discussions because for most people this is like freezing people. I put this always, at least I fight to have this in quotation marks, because we do everything to not freeze you. What in fact, how it does work, basically it works in the following way. So we have a large set of medical teams, all over Europe, in multiple countries, where you can dispatch those wherever you are. We have these medical teams in the US. So if someone signs up with us and says, I would rather be cryopreserved than the alternatives, which unfortunately is only cremation or burial right now. So my point is not, do this tomorrow. Definitely don't do this tomorrow. Hope that all the rest works. This is a backup. This is a backup. If I'm being told by my doctors tomorrow that I have cancer and I have 6 weeks to live, I need to make a choice. That choice is, do you want to be cremated or buried, or do you want to be cryopreserved? And if that's the choice, I'd rather be cryopreserved. I can't tell you if this actually works. You can put people into cryostasis, but you cannot take them out right now. Right? This needs future technology. Of course, you also cannot cure the incurable cancer or whatever else disease you might have. But I'm very confident in saying the chance of you being around in the future is higher than if you're being cremated, at the very least. Right? And unfortunately, these are the only options that you have right now. So we're sending one of all these teams to you, right? These are basically mobile operating rooms. Some of you might have seen one of those. One of those is over there, right? And we cool you down, we avoid ice crystal formation, we put you into stasis, and then we bring you to our research facility in Switzerland. It's a bit north of the Zurich airport, has underground cryo storage, looks like that. Basically, it's like large so-called dewars, 3 meters high, 1,800 liters of liquid nitrogen. Outside, you can touch those, 20 degrees outside temperature. Inside, they're negative 196 degrees Celsius. So extremely cold. The trick here is that at that temperature, nothing happens. There is no aging anymore at that temperature. There is no degradation. There is nothing. So if you need to stay in there for 10 years, or 20 years, or 30 years, or 40 years, or 50 years, or 100, and maybe it's 150, again, I cannot tell you. It does not matter. You can basically wait it out, bridge the time, until in the future, medical technology has in fact advanced enough. It looks like this. So this is a frozen kidney and a cryopreserved kidney. This was done by one of our research partners in the US by 21st Century Medicine. These are the guys who invented the technology behind in vitro fertilization. So it's the same fundamental technology that you use for egg cell long-term cryopreservation for in vitro fertilization. Same idea, in this case with kidneys. So on your left, you see a frozen kidney, right? It's a clump of ice. This was not cryopreserved. This is what we in fact want to avoid. If you warm that kidney up, that kidney doesn't work. It's a clump of mush tissue. It's like putting a strawberry into your freezer and then taking it out next day, warming it up. Not a nice strawberry anymore. No one wants to eat frozen food or frozen vegetables. I mean, to be fair, if you chalk freeze them, it's fine, but not in your freezer. Try it out. Right? On the right side, you have a so-called vitrified kidney. This is a cryopreserved kidney. So in that case, all blood and all water was taken out and replaced against a cryoprotective agent. Think of it as a medical grade antifreeze. It's a solution that if you cool it down to extremely low temperatures, right, in our case at least negative 140 degrees Celsius, it does not freeze. And then now if you warm that kidney up, you take the cryoprotective agent out, you put blood back in, you transplant it back into an animal, the animal survives, the kidney works, everything works. Right? It has been repeated many times now. In small organs, it's pretty easy to do. I mean, in cells, it's an everyday thing. Cells are being cryopreserved almost, or like long-term stored at cryogenic temperatures every day. Organs, in small organs, it works. In humans, you can do the first part. You can put them into cryostasis. You cannot take them out yet. Right? And since I cannot tell you for sure when and if this is going to work, the best thing I currently have is what other people think. So we ask neuroscientists, all right, so cryopreservation, what are the important parts that make you you and that make me me? Right? Everything we care about, memories, identity, personality, consciousness, and so on. How does this work? And of course, we currently don't 100% know how the brain works, but our best understanding is that it's a combination of the cells in your brain, the connection of those cells, all the hundreds of millions of connections, and in fact billions and trillions, and the kind of like an internal computation, what does each individual cell do? And so we asked neuroscientists, what is the basis of all these things that we care about? And a large majority said, yeah, this is synaptic connections and all the things that I just mentioned. That stuff is being kept around in cryopreservation. So for all intents and purposes, as much as we currently understand, the basis of what makes you you, the basis what makes me me, so all the things that we do care about, those things are being kept around. So that for all intents and purposes, it might be possible to bring you back in the future. Now again, it's not a guarantee by any means. So we asked doctors, how high is the probability that you think this will work in the end? So this is a large sample of like 300 something doctors in the US from all walks of life, from GPs to surgeons and so on. We asked them what's your estimation that if you're being cryopreserved under good conditions, that you will be able to be resuscitated in the future and live again. We were very surprised when doctors said, I think the median probability is 25%. Now, 25% sounds very high because we need to remember, every day we're doing operations where the chance of survival is significantly lower than 25%. So in standard medical practice, if you have a ruptured aorta or whatever, the survival percentages in some major things are it's less than 1%. And we still do this every day because we think, okay, it's still worth it to try to save that person. in cryopreservation. So if it's anywhere close to 25%, at current technology, and of course we're working on making the technology better, I'm going to be very happy. To be fair, doctors are not the absolute experts maybe on predicting on how good and how likely technology will work in the future. But we did a sub-analysis, so this is all doctors. Now, if we only ask neurosurgeons, then their average percentage, their prediction is that it works with 70%. Again, small sample size, and then also I don't think neurosurgeons are the perfect people to make that prediction. But in any case, it's much better than these 1% or whatever you might believe. Now, the question in the end for this topic, I think, is very simple. It's not like if people say, I want to be healthy and I want to live long, then it's relatively clear what you need to do for the healthy part. Go to the gym, eat well, sleep well, have a lot of friends, have social connections, do a good chunk of the things that you might have seen today in talks or at the exhibition. So for being healthy, it's relatively clear. We have relatively good data how to be healthy at old age. Definitely don't do any things that makes you unhealthy, like eat bad food, fast food only, do not smoke, do not drink, and all of that stuff. So there, it's relatively clear. How to live longer, unfortunately, it's absolutely not clear at all what you need to do or what you can do. Right? So in the end, that part, I think, very much comes about back to that main question. Do you want to hope that we're going to figure this out? Right? And figuring it out might always mean, we have a major breakthrough on the scientific side anytime soon, right? That figures out all this biology stuff, all this messiness of human biology to extend maximum lifespan. I'm very pessimistic on this point for two reasons. One is that aging and all these fundamental approaches are not yet FDA-approved diseases. So you cannot target aging if you want FDA approval and then later, bring a drug to market and so on directly. So you need to take all these indirect pathways from a regulatory standpoint. And the second main issue is that, let's say you even think, I have something great. I found a drug where I'm very, very, very confident that it lets people live longer. Now, in most cases, you probably need to start giving this to someone when they're like, let's say 60 or something. Now, if you give something to someone where you think it extends the maximum lifespan when they're 60, your clinical trial needs to run for, 20 years, 25 years maybe. And these are extremely expensive. Clinical trials are very expensive, period. But if you want to run it for 20, 30 years, that's prohibitively expensive. So you cannot run these trials in a meaningful way right now. For cancer, it's very easy. Someone has cancer, you give them a drug, right? Either the cancer goes away or they have longer survival. It's very easy to test. For maximum lifespan extension, it's very, very difficult to test. And then again, a lot of stuff in mice you can easily test because mice only have short lifespans, but it doesn't translate to humans. We don't have good surrogate parameters. All these, clocks, epigenetic clocks, so you name it, all of these have not shown yet that they're predictive. As in, it's not clear if you reduce the epigenetic age, this actually means that you live longer. They're correlated, but not yet clear if they're predictive. So it's very, very difficult to figure this out. So I think we're back to this. And now, basically, my closing points are going to be the following. All of you have not all of you, some of you might be signed up for cryopreservation. But most of you have implicitly made the change, or the choice, that if you die due to cancer or a car crash or old age, that you would like to be cremated. Or buried, to be fair. But at least in my mind, between burial and cremation, from a survival standpoint, not much difference. Most of you, if at all, anybody, have not thought about this. Right? Because this is kind of, if you don't do anything, then you're going to end up, unfortunately, after death with burial or cremation. To be fair, I think this is fine. But I would advocate to make this a conscious choice. Say, yes, if I die tomorrow, or if I get a cancer diagnosis tomorrow, then I would like to be cremated. That is my choice. Or say, listen, if I should get incurable cancer tomorrow and my doctors tell me that I have 6 weeks to live or 8 months to live or whatever, a relatively short amount of time, then I make the conscious choice that then I would rather be cryopreserved. And again, I want to be crystal clear one more time. When you're being cryopreserved, I cannot tell you if or when this works. Right? Again, you can put people into cryopreservation, but as of today, no one who has been put into cryopreservation. And now with us in Switzerland, there's somewhere between 30 and 40 people in long-term cryopreservation. There's thousands more signed up to be cryopreserved, when needed. No one of those people have been brought back. And I'm pretty sure that we will not be able to bring anybody back in the next 10 or 20 years. This will take significantly longer. But one thing I am very sure about, that at least based on my worldview, if I get cancer tomorrow and then I'm being cremated, that's it. And I do enjoy life. I pretty much enjoy living every day. I definitely want to see the future. And I definitely, as the intro video said, I definitely don't like the idea of being dead forever. Because there's a lot of amazing stuff going to probably happen in the future, and I would rather be around than not. So if that's my choice, right, if my choice has been between cremation or burial, every day of the week I would say I'd rather take the chance of cryopreservation, even though also I do not know how high the chance is. It's not like we know and then we don't tell anybody. We do not know. Again, no one has been brought back. But the chance is much higher than cremation. So make it a conscious choice between these two options. And if anybody of you says, hey, I would like to learn more to make it a more informed choice, which is very important to us, we have one of our ambulances over there, just out of this exit, right? The team is there. Of course, you can sign up, but you can also ask any and all questions that you might have to figure out if this choice is actually for you. And now, without further ado, think about it, make it a conscious choice, what you want. Thank you so much.